Thank you, everyone. My name is Matthew, like it's already been said. I'm a principal engineer at Instill. And thank you very much for coming. Who's here just to see if they win the Oculus? Because that's the only reason why I'm still here. I'd have been away home ages ago. But we're going to start this session today with a story. And it all starts on Christmas Day, like all good stories. And my wife and I ran down the stairs on Christmas morning. I think it was really early. It was like 5 a.m. because we're two big kids. Ran into the living room, and guess what? Santa had left some presents. Yes. So I tore mine open, and it was this iPad Pro. And I looked lovingly into my wife's eyes, thinking that this is the best wife that has ever been created. And she said to me, it's for us both to share. So on Christmas Day, I gained and lost an iPad Pro. I managed to pry it from her hands this morning for this talk. But ever since I got this iPad, I've always felt like it's a really powerful device that's been limited by the OS that's on it. And it's always felt like there's untapped potential from a developer's perspective. So today we're going to see, can a developer live in the post-PC era? And just to give a quick summary of what we're going to talk about, first of all, we need to give a definition to what the post-PC era actually is, because my colleague Neil, who I'm going to point out here, asked me if this was a decline in political correctness. And I think that's because he works with me all day and he sits in the vicinity of the anti-political correctness zone, as I call it. We're also going to have a look at our demo app that we're going to build from, or add a new feature to from this iPad. So what is the post-PC era? It was a market trend that was observed from like the 2000s to 2010. And really, in simple terms, it's just where mobile devices like smartphones, tablets, and wearables overtook the sale of personal computers. It was a phrase that was made famous by Apple, where they claimed that their iPad was Apple's third post-PC blockbuster. But here we are 9 years later since the launch of the first iPad, and we're still doing all of our development on a PC or a Mac, like a bunch of animals. But why would I want to live in a post-PC era? Why have I tortured myself with this? And just simply because it's what I want to do. This wish list was published just before WWDC, and it's what people wanted from WWDC this year. And number one was Xcode for iOS. Number two was a terminal environment for iOS. And further on down the list was the ability to run virtual machines on iOS. And quite frankly, these things probably aren't going to happen for a few years yet, but it's a dream that we all have. The challenge this afternoon, I've been working on a mobile app and backend for a bank for the past 9 months. So in my head, all I know how to do is bank these days. And the tech stack that we're using for the bank is pretty good. We have a Swift iOS app and a microservices-based architecture using Spring Boot and Kubernetes. But for this talk, we're going to take it one step further. We're going to keep our Swift iOS app, but we're going to replace our back end with API Gateway, AWS Lambda, and DynamoDB. And what we're going to do, we already have our Activate Card endpoint. So if you imagine you've just received your debit card in the post, sort of like what Mons would do, and you have to activate it on the app, we're going to add the ability to block our card. Let's say it has been lost or stolen. And like Steve Jobs would say, it's just going to work, hopefully. So let's just do a quick demo of the app as it currently stands. We'll have a look at our AWS setup and see how that all hangs together. And we'll just do that now. So I will just open up our app here. I will turn this off because it makes it actually run faster. So here we have our iOS app, and this is all built using Swift. And what we can do here is activate our card. So we'll just enter in what's known as our PAN. Interestingly enough, this is not a unique number. So if you think that your card number is unique, it's actually not. Which is one of the challenges that we had in working on this project, was finding a way to actually identify these things. And so you can see I've activated my card, and it brings us to this screen, which I've called the card management screen, where it just renders us a card. So how does that actually look then on AWS? So we have this card management dev stack. And as part of this is a CloudFormation stack, and as part of this we have all of our resources that build up our back end. And the nice place to look here is first of all our API gateway, which is really the entry point to this application. So if we open this up, we see that we have a single post endpoint right now, and this is how we were able to activate our card. If we open this up, you can see what it actually calls through to. So at the very end, you can see here that it calls through to our Lambda, which is our activate card Lambda function. But the interesting thing is I just activated a card, so let's just check that I'm not telling any lies. And we'll have a look in our dynamodb table. So this is really just a simple CRUD app. There's nothing too fancy going on. So we can see here that we have a single entry here for the card that we just activated. And thank goodness that actually worked. So talking about our back end then, I've decided to use the serverless framework for this. This is really just an abstraction on top of CloudFormation. Does anybody here use CloudFormation for anything in AWS? Yeah, so some people know what I'm talking about. It's really just a way to describe our infrastructure as code or as YAML. And serverless is a layer on top of that, which is really tailored for building these serverless applications. You put serverless in air quotes. It still uses CloudFormation under the hood, which is nice because if you've got something custom that you want to add, well, you can just add that to the CloudFormation template. We were at a training course yesterday when the guy said that serverless was a pile of hot garbage. And I was like, oh great, because my talk's using the serverless framework. I think you have to take these things with a pinch of salt. You have to choose the technology that is right for you. And if you want to add an abstraction, there's obviously going to be trade-offs. And for this demo, I found that it was really simple to get started with and take care of my deployments. But how do we actually write code on an iPad? I tried on Boxing Day, just after I got this, to spin up Cloud9, which is on AWS, and it just did not work on an iPad. They're not really designed for touchscreen interfaces. You can also use VS Code, and you can deploy it into a Docker container. Again, that works really well on on a Mac, but it doesn't work on an iPad at all. They just don't work with the Safari that comes with iPad. And then WWDC happened and sort of blew a torpedo right through my talk because they introduced iPad OS, and as part of iPad OS, we now have a more desktop class Safari app, which allows you to use some of these browser-based IDEs. So I saw this on Twitter where somebody had set up the Coder project. They were able to browse to the remote instance of VS Code and use that on their iPad. And if some of you are aware, they also added mouse support on iOS 13 as an accessibility option, which is really cool. Sort of against what Steve Jobs talked about his whole life, but whatever. There's an Apple Pencil sitting on top of my iPad as well, so we'll just glaze on past that. Good work by Apple in adding this in, but if using a browser-based IDE takes off, I think it scares the life out of me, so let's hope that idea doesn't come to life. But what I'm using for my back-end development, I'm afraid to run the iOS 13 beta on this because I was obviously using it for a presentation, so I'm going to use an app instead and not install the broken beta. But has anybody used Coda for Mac or Coda for iOS before? So I started using Coda for Mac back whenever I was in university. It's made by Panic, and they've sort of been in the news recently because they brought out the Playdate, which is the little yellow handheld console with a crank on the side. If you've seen that online, it looks pretty cool. But Coda for iOS it's a really, really good app. They have an excellent SSH terminal. They have a JavaScript editor, which obviously is what I need for this talk. And it allows you to edit remote files. I obviously can't do any real back-end development on the device. So we're going to be connecting to a remote Ubuntu server, doing all our development on there and deploying from there. So let's jump into a demo, have a look at our setup in Coda and do a deployment and have a run through of our tests. So here we are in the Coda app, and you can see I have this nice terminal environment. I've got a checkout of my card management Lambda, and we're just going to have a look at our serverless YAML just to sort of talk through the resources that are in use. So in the serverless YAML, you can specify what provider. It's provider agnostic is what they claim. So we're using AWS in this example. And the functions that we're going to use here, we have a single function, like I've already said, and that's for activating our card, and it calls through to this activate card function. The event that's going to trigger that is a post to card/activate. We can also specify the other resources that we want to have as part of our deployment. And in our case, that is a DynamoDB table called cards. We just specify an ID field for now, and that's going to be the key for that table. We also specify plugins, which is sort of serverless framework is like a plugin-based architecture where you pull in different plugins for different things. I'm going to use local stack to do some local testing on my device, or not on my device, on a device in the cloud, and then deploy to AWS if our tests are all good. So let's just do that right now. Let's jump on here and run our tests. So I can just do npm test. And what serverless is going to do is, first of all, check that we've deployed the current state, which it did. You can see it buzzed by that really quickly because it detected up here that files weren't changed, so it skipped the deployment. And this is all to a local Docker container on this Ubuntu instance. You can also see that we have a fail and test, but like any good developer, I'm going to do some test-driven development today. I have a failing test, so let's go ahead now and implement our block card lambda function, and hopefully we'll run our tests again and all these things will be green. So my wife says to me that whenever I'm working from home, that all I do is copy and paste all day. So I'm not going to turn her into a liar. I'm just going to do exactly the same thing. So I'm going to take a copy of our activate card lambda, and we'll rename this to block card. And we'll open this up. So it's quite simple. It's really just passing through the request to the database. So we want to make a few changes here. Instead of pulling in activate card here, we want to pull in block card. It's just a function that I made earlier, so that this demo would be a little bit less stressful than what it already is. We have this arrow function here for just building up a response. I'm just going to simplify that for our block card. We really just want to return a status code if everything was successful. And then inside this, all we really want is the status code, which is good. Our request that we make whenever we block a card, we're going to pass up our card ID, which would just pull out from the event body. And instead of activating the card here, what we want to do is call our block card function. You can see that the coding experience on iPad is just amazing. Good work to the people at Apple for making this keyboard, a keyboard that actually works. And we'll just save that. We need to also pass in our ID here instead. So that looks good. Obviously, we've made our lambda function. It's really, really simple, but we're not going to deploy that yet until we update our serverless YAML. So let's, again, do what us developers do best and copy and paste. It's sort of scary with all this serverless stuff and these YAML-based config that I think eventually our jobs are going to be just copying and pasting YAML all day. And the only way to write real code is to go work for Amazon or something like that. So we want to add our new block card function. And we're going to say that instead of calling activate card, we'll call through to our block card handler. And we'll update our endpoint to just have card/block. So theoretically, if I run npm test, it should detect that a change has been made, which it has. You can see that it's going to now update my stack locally. And it's going to now run our tests. So activate card passed and block card passed. Thank goodness for that. Another successful demo. The gods must be looking favorably at me today. So now that that's worked, we can go ahead and deploy this. So using serverless, we can just do, serverless has a really nice CLI. Serverless deploy, and we'll just do that verbosely. So it'll do exactly the same thing, and that's one of the things why I like using local stack, although I think the trend now is that we should be testing, doing our integration tests on a real AWS environment rather than local stack. But it's nice to test your deployment as part of your test run, as part of your integration test run, which I think is really powerful, whether you're doing it in local stack or onto like a test environment in AWS. And so what this has done is obviously detected that changes have been made, it's packaged that up. And you can see now it's doing some IAM stuff. It's just creating our lambda function. It's just now created our API gateway method. And you can see here that our deployment was successful. One of the things I like about serverless is that it prints out your endpoints for you. So you can see now that we have 2 post endpoints, one for activating our card and one for blocking our card, which is good. So we'll jump back into our presentation. So for our front end changes then, really on iOS, if you want to do some Swift, you're going to use Swift Playgrounds because it's our best option. I think this is no bad thing though. I think Swift Playgrounds is really powerful in its own way. It's obviously not Xcode for iOS, but it solves a different problem. I think it's great for prototyping UI. It's really, really nice to be able to write some Swift code, see that in a live preview all on this device, and it's a really fast feedback loop compared to deploying to the simulator. Obviously, if you want to deploy to the iOS simulator or onto a device, it has to do a full build and a full deploy onto that. Whereas whenever you're running in Swift Playgrounds, you get this nice live preview. Like I said, there's no need to use a simulator or a device because you're running on the device. And as part of that, then you're interacting with a touchscreen, which I find is really good when you're testing out your user experience. You can make really small tweaks and actually touch it, whereas if you wanted to do that on Xcode, you have to deploy it to a real device. And that was all I was going to say in the matter. But again, WWDC happened, and Apple announced Swift UI, a new way of building user interfaces, and it's a declarative syntax where you just state what your user interface should do. And if you remember from the previous slide, I said that one of the benefits was in Swift Playgrounds is that you have a live preview and you get the quick feedback. As part of Swift UI, Xcode 11 now has this new live preview, which automatically displays your UI changes in real time as you make them in the Swift UI code. You can also do it the other way around and drag components onto the live preview, and it'll then generate your Swift UI code for you, which is awesome. And I think that's a really powerful way for building UIs. I'm hoping that this functionality comes to iPad in some way, where we could destructure our project, where we could build the UI on the iPad, on the real device, and then do the real logic and deployment from Mac OS until you can do it all on iPad. That's the sort of in-between step that I can see. But for now, we can get a similar kind of behavior using Swift Playgrounds on iOS. And the apps that I'm using for Swift development is obviously Swift Playgrounds and Working Copy. And shout out to the person that makes Working Copy. It's an indie developer. I really like using apps that are made by indie developers. And Working Copy is just a way of doing Git check. It's just a Git client for iOS. The UI is not that great, but it works, and it works really well. And it integrates with files. So whenever you do a Git checkout, it actually puts it into the Files app, which allows you to open it up and all the things. So let's jump into a demo and have a look at what we've built in Swift Playgrounds. So we'll just stop this. What we're going to do, we're using the navigator pattern. Is anybody doing any iOS development here using Swift or anything like that? No, just me then. So the navigator pattern is just a way of decoupling your navigation logic from your view logic. And it's, we all have similar sort of concepts in other user interface patterns. But the power of this is that it allows me to change the initial destination of my app just from here without having to rearrange my views or anything like that. But what we obviously want to do today is add the ability to block our card, and we want to build our UI. So instead of having to run my code and view the card activation screen, I'm working in the card management screen. So I would like that to be the first view that I see. So it requires an activated card. So we'll just create for now a dummy card. You can see along the bottom here that I sort of have my autocomplete. Which is slightly different to how you're used to working if you're using Xcode, where you have you hit tab and it completes, whereas now it's just you give it a wee poke with the thing that you actually want. So we'll just set up this with some dummy data. And instead of our initial destination being card activation, this is a enum in Swift. I'm going to say I want to go to card management instead, and I want to pass my card in here. I'm getting an error. Boom. It'd help if I actually knew how to write code. So here we go. So you can see there that I've just made a really small change to my app that I can undo, obviously. And it's taken me to my card management screen here. What we want to do is add a block card button just beneath our card. So let's go ahead and do that now. Swift Playgrounds just got support in version 3. It was like 2 Saturdays ago for separate files, which is really nice and good for this talk. I sort of hedged all my bets and just thought that Apple would fix all my problems before today, and thankfully they did some of that, which is really good. And what we want to do is obviously add our block card button. So let's go ahead and create that now. And we have a button factory, which we can use to create a nice rounded corner button for us. Again, a thing that I made earlier to make my life easier. Our block card button also needs to have a title. So we will have block as our title. And in here, we want that to be for the normal state, or just like whenever the button is displayed initially. If any of you have built, obviously none of you have been using Swift, so you're just going to look at this part here and say, what does that there do? This is pretty much the magic make it all work flag. If you're building your UI programmatically in Swift, you need to set translates auto-resizing masks into constraints to false. Otherwise, it's not going to work. Obviously, you have storyboards in Xcode where you can use the drag and drop interface, but because I'm doing this in code, I need the magic make it work flag. And we'll add this to our view. And hit run. So you can see we're not going to win any design awards right now because our block card button's in the top left corner. But this is what I'm talking about here. We get this nice quick feedback here where we can go ahead and make these changes and see how it goes. So what we wanted to do now is define the layout constraints for this button, where we want this button to be displayed in the screen. And you can do that in this activate block here. We want to give this button some kind of constraints. So you want to say that the top anchor of this block card button, we want to give that a constraint. And that constraint, we want that to be equal to the bottom of the card view. So we can say card view dot bottom anchor. And obviously that's going to put that like right beneath that. We want to add a wee bit of padding. We have this nice margin set up already, so we can just give it a constant. And we'll give this a run and see how it looks. So again, it's not looking too good, but we're now sort of in the right place vertically. Let's give it some horizontal positioning. And for simplicity's sake, let's just say we want this to be centered in the view. So we can specify a center X anchor. And we want to constrain that. And we just want to be the middle of our view. Again, run again. And there we go. Obviously the width's not too nice. There's this concept on auto layout called intrinsic content size, where the text is defining the width of our button. We want to override that and say, let's make our button the full width of our card. So that's called our width anchor. And we want that to be equal to the same width as our card view. And we'll give it a run. So this is looking to be a bit better. We obviously now want to add some functionality to our button. And so we're going to define our targets down here. Targets what happens whenever this button is pressed. UI kit, which is the toolkit for building user interfaces, is still built using Objective-C. So you need to annotate anything that they interact with at Objective-C. And this is going to block a card. And in here we have our card service already defined. And what we want our card service to do is call the block card function. And we give that an ID, which is just our card ID. This completion block is a closure. And because it's the last argument, we can pull it out like this. To avoid any strong reference cycles, we can do weak self and pass in the result. So this is the callback that we're getting for whenever we actually block our card. And Swift has this new type called a result, which is either a success or a failure. And we can switch over that. So we can do switch result. And in the first case here, then we can handle the success. It has an associated type or a value that comes with that enum. And that's just a Boolean that we're returning from our lambda or from our card service. We get a 200 back if it's successful. And we just say, right, success and pass in true. And obviously our default is going to be what happens if there's a failure. So what we actually want to do is whenever we block a card, we want to give a red overlay over our card view. So we'll just create a wee private function now which does that. because this is going to happen as part of a callback, on an asynchronous callback, we need to dispatch this onto the main thread because we're updating the UI. So that's what this block of code now does. We can just get the main queue, and we can asynchronously do some work in that queue. And all we want to do is update our card view. It has a blocked variable, and we just want to set that to be the value of blocked. And we'll also need to have this defined like this. And then what we can do here is simply just make a call to this. And we just want to pass in this instance, we just want to pass in the value of block that we get back. This is our failure, so just for now, we will say update card status, and we'll just set this to false. So what we also then obviously need to do is undo the work that we did in here. And to change our initial destination, we want to actually activate a real card now and see what happens. So let's go ahead and try and activate a new card, and this time we'll just give it all the ones. Activate our card, that worked. Now we'll tap our block card button. Oh, forgot to do something. We need to actually tell our block card button to block a card, so we need to give it a target. So we'll add a target here. And we'll give us another go. So this time we'll do all the 2s and we'll ignore all the 1s. And we'll block our card. Thank goodness. So we've blocked our card. All of the bad guys are going to be kept out of our account. And to just keep me honest, let's refresh our dynamodb table. As you can see here, we have our all the 1s, which obviously didn't work, and we have our all the 2s, which is the value of blocked has now been set to true. So finishing off then, can a developer live in the post-PC era? Who would actually want to do this for back-end development? Yeah, the answer is no to that one. I just don't think it makes sense. But what about for iOS development? Like obviously there's no iOS developers in the room, but can you see, if you were an Android developer and you were doing this on an Android tablet, or you're building web apps, can you see the power of being able to build these applications on the device that they're actually meant to be running on? I think not yet is the answer to this, which makes me really sad as an Apple fanboy. But then WWDC happened, and Apple introduced this thing called Sidecar, which allows you to use your iPad as an external display. And really they're just teasing us now because you can now run Xcode on your iPad, and really it's just a secondary display. But this is the dream that we all have, where we can run Xcode on our iPads. So I was told to put this slide in because I'm a company man. If you would like to spend your hardware budget at Instill on an iPad, you can't do so. And that's one of the hardest parts of working there, is deciding how to spend their money. And is there any questions?